right, looks like it's good. Turn off my camera real quick. All right, so today we have Stan Rhodes and Jacob Fooks. Jacob, I hope I pronounced your last name correctly, but they're presenting today, and I will let them give a little more details on themselves, but they are researchers with CIRA, and they are part of the social science group within OSTI, and they are going to be presenting today on using decision chains to better understand fatal outcomes. So Stan and Jacob, go ahead and take it away.
Thank you, Andrea. I assume you can hear me?
Yes, sounds good.
Okay, great. So hi, everyone. And as Andrea said, I am Stan Rhodes here with my colleague, Jacob Fooks. We are at the Cooperative Institute for Research in the Atmosphere. We are formerly of the Office of Science and Technology. I think we're being integrated into the COOP pillar. We're formerly Social Behavior and Economic Sciences. I think we're something else, Service Delivery Evaluation. I can't articulate exactly what all that means and why that change happened. So I'm just going to skip over that and talk about who Jacob and I are. Once I get my slides going, there we go. So I'm a computational social scientist by training. I'm going to just say I'm somewhere between the new guy and the generalist, and Jacob is the econometrician and analysis guru. And of course, you'll see that reflected in the rest of this talk. So that's who we are. We work day to day with GSUN's team and also the CIRA social science team. So I'm going to go straight into the problem. The problem is that science knows surprisingly little about why people are dying in floods, and particularly the decisions that put them at risk of death in flooding. And thus, we at the Weather Service have little actionable intelligence for forecasters and core partners. And this is our conclusion after reviewing a lot of the fatality records and also a lot of the literature. There's some good literature out there, but there's not that much actually. And so in this presentation, we're going to outline a new, very different and complementary approach to tackling this problem. And by complementary and different, I mean compared to sort of the usual top-down risk communication that looks at flows of communications, we're very much starting with the outcomes approach. So the distinction I want to make before we go any further, and this is really important in the aftermath of Texas, is that there are bigger versus smaller fatality events and how social scientists analyze them. And this is not a hard and fast rule, but this is sort of a way to tease out the difference. For big events, the focus tends to be on key decision makers in the system itself. So sort of the societal, social, technical system. And for small events, the focus is a lot more on the decision making by victims because there's sort of a general assumption that the overall societal system is sort of working as normal. And of course, I'm very much overgeneralizing here to make this distinction clear. There's actually a lot of fuzziness here and there's some overlap and stuff, but I want to be clear that we're focusing on these small events. We've been working on this for a while, and then the Texas flood happened, so it's been really important for us to make this distinction to people. So our key foci, of course, we go back to the our academic alignment with the Weather Service mission, in particular protecting lives, property, and enhancing the economy. We have a real outcomes focus on our group, and so the outcomes we care about in this case are why are people dying, what behavior is putting them at risk. If we're going to care about that, we need to start looking at decision making. What are the contexts? What are the factors that lead to behavior that are putting people at risk? And then doing that properly requires an empirical data focus, right? So then the question becomes, what actual data do we have for people's decision making? And as I mentioned, we have some, but not that much. However, we are making gains, and we're hoping that this presentation will give you some insight in some areas that are developing here. So there's a question sometimes that we have, which is, how do you do social science? How do we answer questions with data? Social scientists answer research questions or test hypotheses with data. And so there's a question of how we do this. So the first approach that we can do, and we've done this, is looking at death data trends. Of course, this uses the storm events database in particular. And this is a very necessary step, but it's not sufficient. So this gives us a good idea of sort of the distribution of deaths, the relative amounts of deaths, and the trends over time. But it does not give us that much information about behavior directly linked to the death. And then there's another approach, which is investigating human behaviors that are feasibly preceding deaths. And that's mostly what we're going to be talking about in this presentation. This is pretty doable. It identifies good intervention points for decisions. You can actually ask people, what they were thinking when they did things and all that, which is, you can't do with storm events. And then we use this risky behavior, such as deciding to drive into a flooded road, as this proxy for deaths, right? Because some percentage of drivers that drive into flooded roads will die, that we have some idea about. So we focus into driving into floodwaters as the risky behavior and then work our analysis from there. So we have a framework for this. I'm not going to go into too much detail about this. I wanted to give you the short version. So this idea and how this is different from sort of the normal risk communication paradigm is we actually start with the deaths and then we trace up the decision-making chain to identify these intervention points. Why do we do that? Because we want to identify those intervention points. And it's not just about the Weather Service in this case. We want to identify whether or not the Weather Service can make a difference or not. And we want to identify possibly where other people can make a difference or not. And that gets back to that actionable intelligence that I mentioned earlier. And again, given our analysis of fatality records, we focus mostly on drivers because they're the majority of deaths on average year over year. So here's our napkin sketch of our framework. So this is a 2-decision chain here. And so this is the idea of the decision chain. On the right, we have entering the road, which may result in someone being injured or killed. And so they made a decision to enter the flooded road or not, seemingly. Maybe not intentionally. Maybe it was a surprise, but there was some decision there. And then before that, there was this decision to drive during an imminent flood event. Of course, there's a question of whether they knew it was an imminent flood event, but there was a decision to drive, right? So this is a basic concept to start thinking about the decision chain and how we think about it. And then we try to identify those factors that matter for those decisions. And a key thing, and I'll probably emphasize this again, is assuming each decision has different sets of factors that matter. So that first decision on whether or not to enter the flooded road, the little research that we've looked at and some of the analysis we're doing on this data indicates that what the vehicle in front of them did is important, whether they have kids in the car, but there are a lot of things that aren't factors. So the purpose of the trip, looking for weather information, so on and so forth. And it turns out often that these decisions are pretty different when we look at what little information we have. Some of the qualitative studies where people interviewed, these decision contexts are different for each of these decisions. And so that means that analyzing them sort of as one big ball where we talk about, was risk communicated and did they take a protective action, really doesn't get us to this, this good outcomes-based approach where we care what decisions are possible places for intervention. And so we can take that 2 chain and we can make a longer chain. This is a chain that starts at the top and then goes to the bottom. I just didn't have room to go across. This is a 5-decision chain. So we have some decisions that we might not know as much about. I have those here. I'm not going to spend much time on them. The idea is just that we can have a chain that as many decisions as we can feasibly say that a general population may make in pursuit of something. And of course, this can get a little hand wavy because you have to make sure to justify that actually, yes, all these drivers did sort of make these decisions. So there's some tuning that has to be done there. So I want you to notice a few things that I'm doing with this framework. First, we're not focused on forecasts at all, and I'm happy to take boos if anyone wants to boo on that. But we have a reason why we do this, and that's because we want to know empirically what matters and what does it for each decision period. And so that's our starting thing, and that complements the risk communication approach, I think, pretty well. And then again, we treat each decision as different, context, timing, factors that matter. It's best to just assume that they're each different rather than assume they're the same. That is a little less tricky and gets us into a little less trouble. And then for each decision, if we have information, then we look at what are possible interventions, right? And that's something that comes as you have more data and are able to do more rigorous analysis. But even at the beginning, you can start to think, okay, what are some possible interventions here? What might those look like and what other data can we collect? So the big so what here is if we want to improve outcomes, we need to identify where we, and that means Weather Service, core partners, and others, can make a difference and where we can't. I think that where we can't seem to make a difference because of the factors that matter for a particular decision is an important and perhaps undervalued thing. And then we also need to know where more research is needed. And so we don't have data for that entire 5-decision chain framework, but we do have some data. And so I'm going to talk about the data quickly before Jacob gets into the analysis of the data. So we have this QRS data. QRS stands for Quick Response Survey. And so this is a quick overview of that. This is key data for an outcomes-based understanding of flood-related human behaviors. This is Brenda Phillips and her team at University of Massachusetts. This started and I think is still funded, but maybe not quite. We're trying to see how to scale it up and transition it as a research project with the WPO. And it's been ongoing for a couple of years. They have a bunch of surveys. They have a lot of variables. They don't just ask about flooding. They ask about some other weather events. and this is in partnership with a few WFOs, and I think that's growing. And one of the key things here is that they put out the survey immediately after a weather event. So the WFO tends to put out a link on social media, and they collect responses, or they have people take these surveys, and the survey collects responses about information sources that the people used during the weather event, perceptions, considerations, and other behaviors. Did they drive? Did they do something else? Did they stay home? What did they do? And this enables us to look at driver behaviors, which is what we're interested in. So we're not looking as much at people that did other things. We're really interested in the people that chose to drove. And so there's a bunch of different factors that are included in this, and I sort of mentioned some of those, but I wanted to give a quick list of what some of those were. The key distinction with a lot of this is that we're asking what people did do. So a lot of research asks people what they would do if they encountered hazards, but we're asking what they did do. And so when we're asking what they did do, we get time and location as best we can, perceived water depths if they encountered water, information received, if they had passengers, took other protective actions, and all that good stuff. And that's what gives us all those like 390 or so variables. So the structure itself is a bit complicated. I'm not going to go over it, but there's a bunch of branching logic to the survey itself. The big takeaways on the structure is the following. One, it has questions about the pre-event and during event behavior. That's really important for us to know. It includes people at home, on foot, and on the road. So we're going to focus on the vehicle drivers for the most part, but it actually does include some additional information about these other people. And of course, you know, people at home and people on foot do sometimes die in floods. So this is still really good information. But again, we're focusing on the vehicle drivers. The early analysis and findings, Brenda did some very initial analysis to see what mattered when it came to drivers driving into flooded roads. And what she found was basically it was just environmental factors. And what that means is essentially they were paying attention to what other cars were doing. They were paying attention to water depth and other things, but almost nothing else when it was analyzed seemed significant. And so we're going to take a different approach here, a bit more of a sophisticated approach that Jacob's going to cover, and we're going to see if our results agree. And the question here is, if we remove all these environmental cues and we're just looking at who people are and some of the decisions they make, can we predict if someone drives into a flooded road? And this will help us start to fill out that decision chain and, again, understand whether or not there's interventions we can do that might help protect lives here. And so with that, I'm going to hand it over to Jacob.
All right, thank you. So, excuse me. So first, I'm gonna sort of walk through motivate the model here and how we approached it. It's a little bit novel and kind of overloads a few methods, statistical methods that are sometimes used for other purposes. It's kind of cool. I'm excited about it. I don't know if anyone else will be. And then we'll go over the results a little bit. So go ahead and advance the slides. All right. So let's think about what we have and what we're trying to do here, right? So we have this data from the CIRA survey. It's this kind of complicated branching thing where we have, a number of questions about what happened, what did you do, and then based on that, you get more questions about what happened next, sort of thing. So there's a number of ways we could have attacked that, but the way we ended up structuring it here was sort of follow the chain of decisions down to the outcome that matter, right? Did you drive through flooded water? Did you die? Did you not die? Obviously, in this case, we only have the not die group, right? If anyone had died, they would not be filling out the survey. So there's potentially a little bit of selection bias there. We'll talk about selection bias in a minute or two. But we're turning this into, this sequence of decisions to match this chain idea and figuring out how to estimate that. So go ahead and next slide. So to put this another way, kind of what I'm going to walk through here is we have this conceptual framework that we've thought about. Right, we're looking at a chain of people choose routes, and then they encounter water. Do they drive through water? There's other stuff that's going on up the chain, and we have a whole bunch of data that's kind of semi-related that has this structure in it, and we need to come up with some sort of statistical modeling approach that ultimately is going to give us some sort of kind of grounded probabilistic representation of individual behavior that looks kind of like a chain of decisions, right? So that's in a very big hand wavy way the way that we're going to go through here. I also want to call out here because I absolutely love this, right? I asked Gemini image generation for like a generic picture of statistical results, and they gave me this thing, which has at the top model, and then complex outputs at the bottom. I really appreciated that. So yeah, go ahead and let's get into this a little more. All right, so I'm gonna again sort of talk through this on a slightly less abstract level to kind of prime you with some of the ideas here. Right, so and then I'll go through kind of in a little bit more detail, and hopefully as things get kind of hairier looking, you'll see these recurring ideas and kind of follow along at least conceptually what we're doing here. All right, so we want to take this data, run some models, and build a chain of outcomes. Now, if we think about how are we going to do that kind of statistically, probabilistically, a helpful way to think about this is, so we're going to kind of start with just our outcome that we want, right? We're looking at the probability of a particular person driving through a flooded road, and we want to know what's the probability that will happen, conditional on a bunch of stuff. And the way that we do this here is sort of a nesting approach, or a recursive approach, where we start with this idea and then go backwards up the chain and then build out around that a series of kind of conditional probabilities. I'm not sure this is a particularly helpful way of explaining it, but yeah, basically we're thinking about things in sort of a nested structure here, right? That idea of nesting will be key. Go ahead and next slide. Right. So, and this is the end point that we want to work towards and back from is this decision that people are going to enter a flooded road, right? And this is something that we ask people in the QRS survey. We say, did you drive through a road, yes or no? And then we can estimate, all right, given one person, conditional on their demographic information, will they drive through a road? And if we look at two people, we say, all right, this person is more likely to drive through a flooded road than this person based on their age, based on their income, based on the information they received, all of this sort of stuff, right? So that gets us a model, right? The probability of driving through a road, conditional on stuff based on the data that we have. However, the problem is that the only participants who are asked that question, did you enter the flooded road or not, are the ones that actually encountered floodwater as they're out driving, right? So do you think that these two people that we see are equally likely to encounter a flooded road? Perhaps not. Perhaps you have an older retiree who isn't necessarily going to be out driving as much. They are less likely to drive during the rain, right? And if that doesn't necessarily, so they in general would be, if there's a warning, they are less likely to be out driving. They are less likely to encounter that flooded road. They are less likely to be asked this question. And if they are out for some reason, perhaps they are out because they have a doctor's appointment or something like this, where they would be less likely to divert, less likely to take alternative things. So we have this problem of what we call selection bias, right? And that's a key idea. This idea that this is sort of equivalent to the decision chain, is this idea that as people are making decisions that get them towards this final outcome, certain groups are selecting out of this at a higher frequency than others, right? So the key to understanding this decision chain is understanding these steps of selection down the chain. Next slide. All right. So this is a little bit more concrete way to think about this chain, right? We asked people, did you know about the event beforehand? If they did, then we can find out, did they take any preparatory action beforehand? If not, we don't know that information. We don't know if they would have necessarily. We just know that they didn't. So then we can, ask them, did you drive during the event? If not, they're sort of removed from that subsample is removed from the final stage. And finally, we get to this end stage, right? So we have this sort of flow of information and people kind of getting removed from the sample as we go. it ends up being quite complicated because of the way the survey was designed, but we don't need to really go into all the technical complications here. Next slide. Right. And so this is what this actually looks like. And I think this is perhaps the most intimidating slide that we're going to have, but also, you know, the most concrete and useful, maybe, if you like concrete and useful, or if you find concrete useful, right? And this is where we really see this nesting doll idea, right? And the idea here is that we want it for any given person in the population. We want to consistently estimate the likelihood that they will be put at the risk of flood mortality by choosing to drive into a flooded road, right? That's our key idea here. We want to be able to identify people, figure out what their risk is. We also have information. We also have information on their information, where they're receiving the information from, so we can better understand potential intervention points, this sort of thing, right? So we have a given person. We want to classify their risk. The way we end up doing this is basis, and you know, so the drive-through flood, this is our final outcome that we're interested in, but that becomes conditional on the likelihood that they encountered a flooded road, right? So before we estimate this, we need to estimate the likelihood that they encountered a flooded road. And then once we kind of can estimate the propensity for that, we can have this be one of the inputs of the final step. But before they encounter a road, we need to estimate their propensity to change plans or reroute, and if they're out driving and it starts raining heavily, right? But before we knew if they changed plans or reroute, we need to know, were they even out driving during the event? If they were out driving during the event or not would be conditional on if they had made preparations that would have decreased the likelihood of them having to drive beforehand, right? Whether they made preparations is conditional on if they knew about this, right? So basically, the way that this is estimated is we start with this kind of, did you receive information from some given source? We estimate this conditional on demographics. We estimate likelihoods that people receive information, and then we use that as an input to the next model. And we kind of go down this, we go into the nesting dolls or down the chain from here and make successive estimations of this. Next slide. So that's the key point. I said we do this successfully. This whole thing can be estimated using a single maximum likelihood estimator. I don't know if anyone really cares, but we ended up doing it in a multi-stage model due to a number of issues here. These are some common issues that one deals with when working with social data that are worth just mentioning. All right, one of these is that, you know, demographic data in general, under best case scenario, tends to be very highly correlated, right? If you know someone's race, you know, you have a pretty good idea of what their education is relative to the rest of the population, what their income is, right? If you know their age, that tells you a lot about this sort of stuff, which makes the statistics kind of mushy if you're trying to include all of this into a statistical model, right? On top of that, and this is really key, and we'll talk about this a little bit more at the end, the data here was gathered by WFOs from their social media, posting on Instagram, Facebook, right? They get a link, they send out the link to their followers fill out the survey. To say that our sample here is biased towards weather interested people is a massive understatement, right? There were some kind of open responses to, like, all right, when you found out there was a flood warning, what did you do? Like, there were several people who clicked other and said that they got onto their computer and pulled up their weather models that they wrote up themselves and ran them to compare them to what the Weather Service was saying and so forth. So this is, and on top of that, relatively white, male, well-educated compared to the general population, right? So that limits the amount of demographic variation in our sample, which just compounds that whole sort of statistical difficulty in parsing out individual effects of some of these things. There's some other stuff. There's some technical issues with how this is done, and because of the way that we're kind of using data from one model to another model, there's identification issues. But plus this ends up being a pretty huge model just in terms of huge not huge, not relative to like a numerical weather prediction model, but huge relative to so some more simple kind of demographic regression type of models. We end up with hundreds of parameters and only like 1,300 observations of people who actually completed the survey. So our degrees of freedom end up getting stretched pretty thin. Next slide. All right, so results, and I need to step on the gas here and go. So basically, I'm going to go through the results. There's 3 things I want to convince you of. First off, and our key thesis here is that this decision chain approach is a good approach. I want to argue that this did kind of when we estimate it by leveraging the selection effect, it does a both significantly and substantially better job of fitting the data than if we look at any particular decisions in this individually, right? This does a much better job of explaining the data. The kind of corollary to this, that is, if one does not take this selection into consideration when estimating some of this data, you're going to have biased results, right? So these are sort of better unbiased, less biased estimates than one would otherwise get, right? Secondly, and sort of the practical thing of interest to us is we're trying to kind of classify behavior to identify intervention points, and we do see a fair amount of demographic heterogeneity all along the chain of behavior, right? You see different people making different decisions at different points, as well as receiving different sources of information, right? So this means that there is, even based on this fairly limited sample, a fairly rich kind of what is an economist I would call a policy world, even though it's not policy in the way that most people think about it. But there's a rich space that we could think about applying some sort of intervention to improve things, right? Which is point C, right? This gives us insight into more how to effectively target and identify and target interventions to individuals at higher risk of flood mortality. Onwards. All right. So my first point here is decision chains give better results. And we have tables and tables and tables of little texts and numbers and stars and stuff. I'm not going to go through that too much. But this is kind of the one thing that I want to point out here to make this point is just this is looking at that final step. Did you drive into a flooded road or not? In looking at that with and without the that kind of bias correction factor or the selection factor, right? And that's this thing at the bottom. We see that is quite significant, and on top of that, we see that once we account for that, a lot of the other things that we see as marginally significant before that end up becoming less significant, smaller. So there is this selection bias that's going on when we don't include this, and when we do include it, it does add a fair chunk of descriptive power to the model. So there's basically 5 models that we're looked at. Let's 1, 2, 3, 4, 5. 6 or 7 steps in the chain here. I can't count and talk at the same time. They're basically 4 models that really ended up telling us a lot. And I'm going to go through the results for a little bit. And so these are steps. The next slide, I think, is useful. Yeah. So each of these steps represents kind of a regression type model that we'll kind of step through some of these results. Each of these steps have sort of all their own individually interesting results that one can parse out. But again, because of kind of the sample, there are some questions about how much one can resolve in this, and talk about that a touch more at the end. Next slide. So in general, looking at this step by step, we start off with where are you getting your weather information. We looked at several sources of information, and we do see differences in who is accessing information from different sources, right? You have males, people in manufactured home are more likely to get information from the National Weather Service, for instance, whereas Black people are less likely to get their information from the National Weather Service. If we look, so then that sort of feeds into step 2, where we ask, okay, did you know about the event beforehand? And we find that older people, homeowners, those who get their information directly from Weather Service are more likely to know about the potential for flooding beforehand than others. All right, so once we know whether or not you knew about the event, then we can say, okay, did you make preparations for the event? And we see some other sort of demographic differentiations here, right? You see that Black people, young people may be more likely to alter plans, whereas, and there were a couple other things here. Anyway, there's a number of different options for steps that people may have taken, and we see people responding to this, making those decisions differently, based both on their demographics, and I didn't put any of the weather information thing here, but we do have some weather information included in that. Once we know whether or not they made preparations, then we can look at, did you choose to drive during the event? And this, we see a lot less sort of specific demographic variation here. All of this ends up coming down to what preparations did you make, along with what prior flooding experience people had. And then, as the sort of the further we go down this chain and the closer we get to the event, the less difference there is in terms of demographics and information and this sort of stuff. And the more it's just about, like, once you find yourself here, it becomes less demographic, more just about environmental factors, right? Next slide. So this is sort of the crux of this. If I've been rambling and all over the place too much and you've kind of stopped paying attention to me, start paying attention now again. This is sort of the third key point that I want you that we want you to take away with, right? So if we just look at that, did you drive through the flooded road question? Our data does not say much about that on its own. Right. And this is very consistent with other analysis, other publications, which suggests that the primary factors that influence decision to turn around are environmental, right? It doesn't matter how much information they got. It doesn't matter that people said turn around, don't drown or whatever. Like, once they get to the flooded road, they're at the flooded road, and there's nothing you can do to change the outcome at that point. Next slide. Right. However, if you look at this in the context of the whole chain, suddenly there's a lot more that we can say here, right? So we know that while there's the kind of demographic variation, all that sort of stuff doesn't necessarily affect whether they flood through the road or not. We do see that the decision to drive is contingent on preparations, and we see that different groups are more likely to take different preparations and this sort of thing, right? So next slide. So if we just look at that last couple steps, and we're approaching this data from a perspective of, all right, what can we learn from here that will improve outcomes? And we run some models and we say, well, like, there's nothing we can do, right? There's not much room for intervention here because there's not much that seems to affect people's decisions once they get to this point. But next slide, right? But we may be able to encourage people to select themselves out of the chain, right? There are opportunities for intervention up above them, further up the chain, that we can, that there is room to intervene and keep them from getting to that sort of last choice where, by which point there's really not much of an opportunity for intervention. Okay, next slide. So future directions. So we presented sort of some initial results here. We also presented one of the more challenging issues, right? They're not jaw-dropping, they're not super surprising, but really what we wanted this to be was, first off, kind of a test case for this approach of modeling this as a chain of decisions and trying to think about, how do we model this as a chain of decisions? It was a pretty limited data set, but we did find some pretty strong results, which is a good sign. Our next major step is basically we want to get a more representative sample. We want more representative data. We know that these are very weather interested people. We know that these are fairly demographically uniform people. Excuse me. So we're working with Brenda Phillips right now to get some more. Have Ipsos, a survey company, is going to be running some of these surveys with some of their representative panels, so that instead of going through the WFOs, they're being run by a survey company to try to get kind of statistically valid, generalizable results. We're looking at Austin area for the recent flooding there, Chicago area, and kind of the New York, New England area, all of which have recently had flooding. So we're doing this as a follow-up there, right? There's also questions of applying this to other hazards. Brenda has fielded the survey for a number of different hazards. And of course, the sort of decision context of all of those is different. And the extent to which they are kind of a result of this chain of decisions or not may vary. So there's a lot of opportunity to really apply this in different contexts to understand kind of to even better understand what are kind of the behavioral decision space differences between these different hazards outside of just kind of the obvious meteorological differences. And I think that's about what we've got. The end. So thank you. I don't know kind of where we are on time and so forth for this generally, but we're glad to discuss, question whatever people have. If you are terrified of speaking in front of this group of illustrious colleagues, do feel free to drop us emails. Always glad to chat about this stuff. And I will stop talking now for a minute.
Thank you guys for presenting here. If anyone has any questions, please feel free to drop something in the chat or raise your hand. Give it a minute or two, and if not, we can wrap things up. So I did want to make note, Brenda Phillips was mentioned a couple times in the presentation, and she is actually having a presentation next week with the HMT Summer Seminar Series. She's presenting societal responses to flash floods. So if you're interested in learning a little bit more about the social science side of flooding impacts, check it out. Let me know. I can give you guys a link to the seminar series if you don't have it. I guess with that, we can go ahead and wrap things up. Thank you again, Stan and Jacob, for presenting. This was really insightful and helpful. I think something that the field can really benefit from hearing about. This recording should be available in a few days for anyone who may be interested in watching it, listening to it in the future, but wasn't able to attend today. And we will be sure to share it when it does become available. So thanks again, Stan and Jacob, and thanks to everyone for attending. Hope everyone has a great rest of your week, and we will see you next time.